do a few of these and we'll solve these by factoring. So first few, we need factors of 21 that add up to 10, so that'd be plus 7 and plus 3. So it's either x plus 7 equals 0 or x plus 3 equals 0. So x is going to be equal here to either negative 7 or x equals negative 3 by the time we move things over, right? Minus 7 on both sides, and then you could subtract 3 on both sides. For number 2, we need factors of 6 that add up to be negative 5. So I believe if we do minus 3 minus 2, that'll do the trick. Again, you're more than welcome to use the box there. And some of these I will end up using the box. So it's either x minus 3 equals 0 or x minus 2 equals 0. So here x equals 3 or x equals 2. Over to number 3. Here's one of these where we need to move everything to one side of the equation. So we'll subtract the 4x. We'll subtract the 5. That'll leave 0 on the right side. So I need factors of negative 5 that add up to be negative 4, and I believe we have negative 5 and plus 1. So it's either x minus 5 equals 0 or x plus 1 equals 0. So here x is either equal to 5 or x equals negative 1. What you should be noticing, actually, it ends up being the opposite of what's in the factor above. Here we go for number 4. I'll go ahead and use the box method here just so we see that playing out. So we have 2x squared, excuse me, I have 2x squared in the top corner of the box. I have 20 in the bottom. So I need factors of 40 that add up to be 14. I believe I have 10, 4. But suddenly I see an issue with this before we even begin. There's actually a common factor that I can pull out of all of these right away. Probably not going to be a big deal in the end, but it could cause us some confusion along the way. So here I can pull out a 2x, here I can pull out a 4, here I can pull out a 2x, and I can pull out a 10. So the two factors, 2x plus 4, 2x plus 10. So set those two things equal to 0. 2x plus 4 equals 0, or 2x plus 10 equals 0. I'm going to do a little bit of work here, two-step process. So 2x equals negative 4, divide both sides by 2. So x equals negative 2. Subtract 10 from both sides. We end up with 2x equals negative 10, divide both sides by 2. X equals negative 5. And I mentioned that there might be some confusion here because if you FOIL this back out, it's actually not going to look like the original problem, but it is in fact, you still end up getting the right solutions. So move on here to number 3. Here's one, we got to get the 4 over to the side, so let's move that over. So 3x squared, I'll do it in black, that way we can see the original problem. Move that 4 over by subtracting it. Then now, setting up my box, I have 3x squared here, negative 4, so I need factors of negative 12 that add up to 11. I believe that'd be 12 and minus 1. So 12x minus 1x. Pull out what I can, so I can pull out a 3x here, I can pull out a negative 1, pull out an x there, and I can pull out a 4. So my two factors here, 3x minus 1, and then x plus 4. So I set those both equal to 0. 3x minus 1 equals 0, or x plus 4 equals 0. So add 1 to both sides over here. 3x equals 1. Divide both sides by 3, so x equals 1/3. So it's okay to get fractions. Or when you subtract 4 from both sides, x equals negative 4. Either one of those should work. Number 6, kind of don't have a whole lot of room. I need to move that x over. And just to keep this thing in standard form, I'm actually going to squeeze it in since I subtracted it, minus x, minus 15, just to keep things in the same pattern that I've been working with so far. So I need 2x squared here. I need negative 15. So I need factors of negative 30 that add up to be negative 1. I believe that'd be negative 6 and 5. So we have minus 6x, 5x, pull out my common factor, so I got a 2x that I can pull there, a 5 here, an x here, and it looks like I can pull a negative 3 out of those two. So my two factors here that I'm going to start working with, 2x plus 5, and x minus 3, and just set both of them equal to 0 and solve. 2x plus 5 equals 0, x minus 3 equals 0. Well, that one's pretty easy. X equals 3 on this side. Here, subtract 5, so 2x equals negative 5. Divide both by 2, so x equals negative 5 over 2, or x equals 3. And then two more problems for us. Again, we got to move that 3 over. So 8x squared plus 10x minus 3 equals 0. And while I'm moving stuff, I'll go ahead and move, if you look at number 8, x squared minus 11x, I got to add the 24 over here, and that equals 0. So take a quick second with your box method. 8x squared here, negative 3, so we need factors of negative 24 that add up to positive 10. I believe that would be 12 and negative 2, so we have 12x minus 2x. So the common factors here, I can pull out a 4x. I can pull out a negative 1. The only thing I can get out of 2x and negative 3. Again, we started with a negative, so we pull out a negative. Here, we're starting with a positive 8x squared. It kind of looks like a third. I'm sorry about that. So I can pull out a 2x there. I can pull a 3 here. So now two factors, 4x minus 1, 2x plus 3. Now just set them both equal to 0. So 4x minus 1 equals 0, 2x plus 3. This one we're going to end up with fractions on both of these. So 4x equals 1. Divide both sides by 4. So x equals 1/4. Or subtract 3 from both sides. So you have 2x equals negative 3. Divide both sides by 2. X equals negative 3 over 2. And the final example for you guys, we need factors of 24 that add up to be negative 11. I think that would be minus 8 and minus 3. So this one's pretty straightforward. So x equals 8, or x equals 3 by the time all is said and done.